record right when I tried to unsleep the computer. I wasn't totally ready, but now I'm ready. We're going to get started. We're going to call this solving two-step equations with fractions. Now, this is a little different. This is very, very similar to stuff we've done before. So I'm going to review that first. But I'm teaching you today a trick. And this trick is going to make fractions disappear. It's going to make your life so much easier.
I love this trick.
Okay? This is not, it's not really anything new. It's just a different approach and a trick to make some things easier. So when we say a two-step equation, just to remind you guys, what we mean is something like this. 3x plus 1 equals 10. And the reason we call that a two-step equation is because I can't get x all by itself by just doing one thing. I can't just divide by 3 and get my answer, right? What do I have to do first in this equation? To solve for x. Yeah, I have to subtract the 1 from both sides, and then I have 3x equals 9. This now becomes a one-step equation, right? And so to solve this, I'm going to divide by 3, divide by my coefficient of x, and I'll get x all alone on one side, and on the other side of my equation, I have 3. So my answer is x equals 3. And I can plug that in and check it. So I'm going to say 3 times 3 plus 1. And my question, does that equal 10? And then I see 3 times 3 is 9. Plus 1. Does that equal 10?
Haven't we done this before?
9 plus 1, 10. Yeah, this is a review. Okay, just a review of what a two-step equation means. We have an equation, so we have two sides and an equals in between them, two expressions.
What's that thing right
with an
there?
equals sign in between them.
What is that though?
What is what?
Like it looks like a 3 over 2 lines.
Here?
Down.
Oh, this is like when we check an equation, it's like a question mark.
Oh.
Does this equal this? Okay. We don't know if they're equal because we're checking. We're checking to see if they do equal. Right? And then what I like to do sometimes is put a check there when I've checked.
Wait.
Oh, then that's the answer?
The answer was
Oh,
x equals 3.
Okay. So we got to do
But I wanted to check to make sure that I didn't make any mistakes along the way. So I took x equals 3. I plugged it in for x. So then I rewrote that here. 3, instead of x, I put 3 because I think that x is 3. So 3 times 3 plus 1 equals 10.
So is it required to do the bottom one too?
This is not necessarily required,
Okay,
but
we can.
highly advised, right?
Okay.
If you make a mistake on a quiz, you can actually correct your own mistake. So on a quiz like this, there's no reason not to get 100%. Because once you find your answer, you actually have a way to see if it's the correct answer. It's like, it's kind of like I've given you all the answers, right?
And we just have to...
You're checking your work. So there's no reason not to get 100%.
Oh, that's cool.
So it's really worth it to spend some time checking answers. Anyway, this has been a review. Two-step equations. Two-step equations. So what if we have an equation like this? 2/3 x. So this means 2/3 times x, right? Plus 1/3 equals 9/3.
So minus.
Okay. Now, there's a trick to doing this.
Wait.
Now that you know the distributive property, watch what I'm going to do. I'm going to show you something. I can multiply any side of the equation by anything, right?
Right.
I could multiply this times whatever I wanted, as long as I multiply the other side of the equation by the same thing. I'm going to look at my denominators. 3, 3, 3. What happens? What happens if I multiply a fraction, like 1/4, times its own denominator? What happens when I do that? So I could imagine like 4/1.
It'll be 4/4.
That'll be 4/4, which is just
1.
1. Okay. So wait a second, that's not a fraction anymore. I started with a fraction. Maybe this is just a fluke. What if I had like 3/4 times, I'm going to multiply that times 4. So let's imagine that 4/1. We don't really have to write 4/1 because we know it's the same thing, but it might help you see what happens. What do I get? Okay, so I could get 12 over 4 times 1 is 4. Wait, 12 over 4 is 3. That's not a fraction anymore.
How is it?
Does anyone notice something about this number and this number?
1, 3. They're all.
Let's do another one. 5/7. Multiply that times the denominator, 7. Okay.
So all your
5 times 7 is 35 over 7. 35 over 7, though, is just 5. Wait a second. I've seen 5 before.
They're giving one
aren't you dividing 7 by 3? And you
Hmm.
multiply the denominator.
What is going on here?
5
Let's
over
try
3.
another one. 4/5 times 5.
20 over 5.
25.
Okay.
Yeah.
And then that would be
4.
Oh, put a 1 under the 5.
Seen a 5. Okay, maybe that's going to help you think about these, to put a 1 under there.
Yeah.
Put a 1 under here. What's going on? Here I got 1, and I started with 1/4. Here I got 3, and I started with 3/4. Here I got 5,
And you started with 5.
and I started with 5/7.
And then over there you started.
What's happening here?
So the numerator is the half.
Yeah, when I multiply a fraction times its denominator, like 1/3 times 3, essentially, I can cancel my multiplication. Remember, when I multiply fractions, I can cross cancel. So I can cancel this 3 with this 3. Right? I don't even need the over 1. I can still cancel this. So it'll just be 1. So 2/7 times 7, I'm just going to cancel my 7's, which is going to give me a 2.
Oh,
Oh,
I see.
yeah.
Okay.
Do you see this pattern? What's going on?
Yeah.
It's like,
Take
what?
So let's think about what I could do up here. What can I do with these? I'm going to multiply by 3. I'm going to multiply this side of the equation times 3. And I'm going to multiply this side times 3. Now watch what happens. Distributive property. Okay? I can't forget to distribute because I'm multiplying the entire side of the equation by 3.
Oh, so now
I'm not multiplying 3 times this. I'm multiplying 3 times this whole thing. So even though there weren't parentheses there, I'm going to put them in there
And
to show that that's what I'm doing. Okay, now I'm going to distribute. I have 3 times 2/3 x plus 3 times 1/3 equals, and I'm going to write this one the other way, 9/3 times 3. What do we just see? When I multiply times the denominator, that's just going to cancel. Whoosh.
2x.
This is going to be 2x. This is going to be
Plus 1
1. This is going to be
equals 9.
that seems so much easier than working with all those fractions. In this one, I would have had to use the reciprocal and multiply by 3/2, and I would have had a fraction times 3/2. Ugh. Ugh.
terrible.
This way, I just have to do what?
Solve it.
Subtract 1 from both sides. 2x equals 8. And then divide by 2.
8 equals 4.
X.
2.
X equals.
Oh, it's so simple.
Are we going to do anything else besides?
Yeah, these get a little bit more complicated. So I'm going to do one more example like that. Example number 2. What if I had 1/5 x plus 2/5 equals 9/5?
We are going to
Multiply by
5.
5. Remember to multiply both sides of your equation. And remember on this side, the 5 will distribute to every term because you're multiplying the side times 5. Okay, 5 times 1/5 x is just 5 cancels.
And then it'll be 1x.
Yeah, 1x. Do I need to write the 1?
No, you just need to
No,
write
I'll
x.
just write x. Okay. 5 times
2.
2/5 is 2. 5 times 9/5. This one's even simpler. Beautiful. Okay, what if I had this problem? 1/3 x plus 2 equals 4/3.
You multiply by 3.
Yeah, I'm still going to multiply by 3. I still don't really want those fractions there. Even though I have fewer fractions, I'm going to choose to do this. I don't have to do this. I could solve it by subtracting 2 and multiplying by 3. It wouldn't be that hard, really. But this will make it even easier. So multiply by 3. Now, 3 times 1/3, I'm just going to have x. What is 3 times 2, though?
6.
Yeah, so in this case, I didn't have a fraction here. I have to still multiply that times 3. Okay? Because it's still one of the terms. Even though it doesn't have a fraction, right? I'm still multiplying that times 3. So 2 times 3 is 6. And then 4/3 times 3 is 4. Because those cancel in that case. Now I'm going to subtract 6. And I'll have x equals, what is 4 minus 6? -2. Very good. Super quick. Super quick answer. 4 times 4 minus 6 is -2. One more trick. One more trick. But before we do the last part of this trick, I'm just going to remind you of something. When you had a number like 1/2 and you added it to another number like 1/3, what did you have to do?
You have
Same
to
denominator.
multiply
Yeah, you have to find the lowest common denominator.
Oh.
What is the lowest common denominator here?
2.
6, right?
Yeah.
And I find 6 by multiplying this times 3,
And then
multiplying this times 2.
And then
So then I have 3 sixths plus 2 6 equals 5 sixths. Right? Okay, so 6 was my lowest common denominator. Now, if I had a problem like this, 1/3 x plus 1/2. So notice, I'm not done writing this, but notice already the fractions are different. So I can't just multiply by 3 because that won't clear this fraction. Right. So what I'm going to do is multiply by my lowest common denominator. Okay. So 1/3 x plus 1/2 equals 2/3. I'm going to multiply by my lowest common denominator, which was 6. Now, this is going to be a little bit trickier. Be a little bit trickier. Not too much trickier, but a little. 6 times 1/3. 6 times 1/3. Now, this is still going to cancel with a 3. The 3 is going to go away. But I still have a 2 left. So now I have 2 times 1x, which is 2x. So the 6 cancels, but it doesn't cancel all of the 6. And that's always going to happen when you need to find your lowest common denominator. So 2x. Now the 6 cancels with the 1/2, but it leaves what number?
3.
3 equals, and the 6 is going to cancel with the 3 over here, but it's going to leave what number?
2.
It's going to leave a 2. So then I have 2 times 2, which is 4. Okay, so I multiplied my 6 through. It canceled with the denominators, but there was still something left to multiply through. So 2x plus 3 equals 4. I'm going to subtract 3. 2x equals 1. Divide by 2. X equals 1 divided by 2, 1/2. So my answer is a fraction. But I didn't have to do any fractions in between. I didn't have to add or subtract any fractions to get it.
It's not really what I
So sometimes your answer will be a fraction, and there's nothing you can do about that. If x equals 1/2, you can't like clear out the 2, because then you would have 2x. We want to know what 1x equals. Sometimes your answer will be a fraction. Okay. Yeah.
This isn't exactly what I expected. When he said that we're going to be like deleting or taking away fractions, I thought that we were going to remove them from the problem completely. And actually...
Yeah. And we did, like from here to here.
No, but like in that problem, just erase the 1 and the 3. X,
Oh, just like erase them?
And then just do the 2, 3 times x.
Can't do that. That's not one of the laws of algebra. The eraser law of algebra. Whatever you erase no longer exists.
Oh, I like that.
All right. Okay.
Can I borrow the
Let's do some weird examples. Ready? 1/3 x plus 2/3 equals 1/2. What am I going to multiply by?
By 3.
Hold on, let me put this down.
I have a 3 here and a 3 here, but look, what do I have here?
6.
2. So what's my lowest common denominator? 6.
I like
Multiply this side by 6 and this side by 6. 6 times 1/3 x is?
The 6 will be a 2, and then
Yeah.
that would be
2x.
Yeah, 2x.
And then 6 times 2/3.
Would be 4.
Uh-huh. Very good. And then 6 times 1/2.
Would be
Okay.
And you subtract 4.
Subtract 4.
And then it'll be 2x.
3 minus 4.
1.
Negative 1, right? Because this one's bigger.
Yes.
Then divide by 2.
Then you divide by 2, and then it'll be negative 1.5.
Negative 1/2, right?
Yeah.
So this time I got a negative fraction as an answer. But I think it's a lot easier to get there by doing this than it would have been if I had like subtracted 2/3. Okay, what's 1/2 minus 2/3? Okay, now I have to multiply by 6 anyway to find my common denominator, right? And then I'm going to have to find the reciprocal of this. Okay, multiply by 3. So then I have to multiply my fraction by 3. Do you see how if we had done it that way, just like this, just solved this, 1/3 x plus 2/3 equals 1/2. If I had subtracted 2/3 from both sides, this is kind of messy. 1/2 minus 2/3, that's not really that easy to do, right? We probably have to go over in our workspace over here, 1/2 minus 2/3. And then we'd have to like multiply by 3, and it would get kind of like a long problem. It would become a long problem. But just multiplying through to clear my fractions, which is what this is called, clearing my fractions, makes it into a much easier problem. 3 minus 4, sure it's negative, but that's a pretty simple addition to do compared to 1/2 minus 2/3. This is a lot easier. So the whole goal of this is just to save us some time and save you from making any mistakes.
It's a lot more work than the other one.
It's more work than some two-step problems, but it's easier than it seems at first, right? If I had given you this problem at the beginning of class today, right? You would have been like, what? You would have known the steps to solve it. Subtract 1/2, right? Multiply by the reciprocal. So you would have been able to solve it, but it wouldn't have been quite as easy. Instead, we're just going to multiply by
3. 6.
Yeah, 6. We could multiply by 3 if they were all 3's. We have to multiply by 6 in this case. So,
If the common denominator is
whatever's your lowest common denominator is what you multiply by. 6 times 3 is going to be,
2.
yeah, so it's going to be 2, but then I also have a 5 here, so that's going to be,
20x.
what's 2 times 5? 10x. Plus 6 times 1/2 is
3.
3.
And then
6 times
14.
7/3.
14.
Yeah, very good. 14. Okay, now what do?
Now you subtract 3. And then it'll be 10x.
Equals 1.
And then what?
And then you
Divide by
multiply 10, and then that would be
11 tenths.
11.
Yeah, 11 divided by 10 is just 11 tenths. Now, this answer, that's an awful fraction. 11 tenths.
Ew.
That would have been really, really complicated if I had like subtracted 1/2 from 7/3 and then multiplied by 3/5. Eventually I would have gotten 11 tenths. Right? But I think this way of getting there is a lot easier. It doesn't become a fraction until the very last step. Right? We're not really working with fractions until our very last step. So that's the idea. You still will get kind of weird answers for some of these problems, but you get there just by adding and subtracting and dividing. Pretty much all. Okay. Time for some example problems.